This is a recording regarding homogeneous transformation. Part A. Given the object ABC that has an image 1, A prime, B prime, C prime. Through a transformation P. Name the transformation P. We can see from the diagram, the transformation P is a translation. Notice that this is a translation moving to the right and upwards, say C to C prime, B to B prime, A to A prime. So you can see that they all move in the same direction. Therefore, P is a translation. So you can write the answer. P is a translation. For more detail, you can say that, for example, C is the point x equal to 4, y equal to 1. C prime is a point x equal to 6, y equal to 5. Therefore, P is a translation moving to the right 2 units and upwards 4 units. And this will provide you the translation required. This answer part A. Part B. The object triangle ABC, as shown here, goes through a transformation Q to get image 2, which is here, A prime, B prime, C prime. Write down the homogeneous transformation matrix Q. First, we must identify what is this homogeneous transformation Q. This transformation is a rotation. As we'll see later how I get this rotation. This A to A prime, you notice that I actually rotate 90 degrees. Same thing, B to B prime, rotate 90 degrees. C to C prime, also a rotation of 90 degrees. So notice that image 2 is obtained by rotating triangle ABC 90 degrees anti-clockwise. So let's recall the matrix of rotation of 90 degrees. Let's look at a picture rotation object shown in the course book here. If an object from xy rotate clockwise for angle alpha to a point P prime, give you x prime, y prime, then the matrix of rotation is this. Notice that this alpha can be positive or negative. Now that means that if the rotation is clockwise, alpha is positive. If the rotation is anti-clockwise, then alpha is minus. So for our case, since we are rotating 90 degrees anti-clockwise about the origin, therefore alpha is negative 90 degrees. Hence, the metric for Q according to the notes is cosine alpha, sine alpha, minus sine alpha, cosine alpha, then 0, 0, 1 in the last row and last column, put alpha equal to minus 90 degree, then you get Q equal to cosine minus 90 degree, sine minus 90 degree, 0 minus sine minus 90 degree, cosine minus 90 degree, 0, 0, 1. Now press the calculator, you know cosine minus 90 is 0, sine minus 90 is minus 1, negative of sine minus 90 is 1, cosine minus 90 is 0, and this will give you the metric Q. Part C. The object ABC goes through a transformation R to get image 3. So let's look at the object ABC is here and go through a transformation R to get image 3, which is A prime here, image 3. Describe inverse the transformation. You can see for yourself that this is again a rotation of 90 degree. For example, C rotate 90 degree to C prime. So this R is a rotation 90 degree clockwise about origin. So this is an object rotation, so you can write invert now. R is a object rotation, rotational object 90 degree clockwise about origin. Part D. Explain whether the image of ABC that goes through transformation Q then R is the same as image obtained from Q then R. Recall what is Q and R. Q is the transformation that moves ABC to image 2. So this transformation is Q. What is R? R is the transformation that moves ABC to image 3. Now, we will expect that if you first do Q then R, you should get the same image as doing R then Q, because Q is a rotation about origin anti-clockwise 90 degree. R is a rotation about origin clockwise 90 degree. Apply these two consecutive transformations, you expect the same image, and the image should give you back ABC. You can check by doing matrix multiplication. First, matrix of Q we have find earlier is cosine minus 90, sine minus 90, minus sine minus 90, cosine minus 90, 0, 0, 1, and this is equal to 0, minus 1, 0, 1, 0, 0, 0, 0, 1. And R is equal to almost the same, because now it is a clockwise rotation now, because of 90, sine 90, minus sine 90, cosine 90, 0, 0, 1, which will give you 0, 1, minus 1, 0, 0, 0, 1. So if you apply the transformation Q then R, first Q then R, then the combined transformation matrix is R times Q. And when you multiply, you get the identity matrix. Now, if you first R, then followed by Q, then the combined transformation matrix is Q times R. You also get identity matrix. Since the matrix are identical as Q times R and R times Q and R times Q the same, so we will expect that the image will be the same. In fact, the image is ABC again. The object ABC undergoes a sequence of transformation to obtain image 4. So let's look at the picture. Where is my object? Is here ABC and undergoes a sequence of transformation to get image 4, A prime, B prime, C prime. In your opinion, what is one possible sequence of transformation to obtain image 4 from the object ABC? Notice the highlight is a sequence. The question indicates that we are looking for a sequence of transformation. What is one possible sequence of transformation? That means you have to give a series of transformation that will produce the image 4 from ABC. Here is one of my suggestions. There could be some other. First, you make a reflection of ABC in the x-axis first. So you make a reflection in the x-axis. So you get this image coming out. Somewhere here. First, you make a reflection in the x-axis. So this is, okay, let's say A prime, C prime, B prime. Then you make another reflection in y-axis. Then you get a second image now, which will be here. And this will be A double prime, B double prime here, C double prime. And then you do a scaling. Now how much do you scale? Notice that first we note that the length of A double prime, C double prime is 3. It's the same as AC. And the length of the final image of 4 horizontal length is 8. So you have to do a scaling or enlargement in the horizontal direction. The ratio is 8/3. And then you look at the scale factor in the vertical direction. Notice that the original vertical length of the triangle is from 1 to 3. So this is 2 here. And the final image, the vertical length is, you can get this is from 1 to 6. So this is 5 here. Therefore, the scaling in the vertical direction is 5 to 2. So this is a scaling. Third one will be a scaling. I can write down horizontal scaling factor is 8 to 3. Vertical scaling factor is 5 to 2. Horizontal scaling factor is 8 to 3. To summarize, these are 3 transformations we do. First, reflect about the x-axis, then reflect along y-axis, then enlarge by a factor of 8/3 in the x-axis, and a factor of 5/2 on the y-axis.